So today we'll be talking of a rotational motion. I think in our class we have Preetham and how many students joined the last class?
So 3 students, and there was a new student, sir.
Okay. Hmm. Okay, we continue. Whoever will come, they will keep on joining. We should not stop. Otherwise, we will be wasting our time. So see, as a part of the rotational motion, we have seen the Newton's laws of motion, and we know that the Newton's laws of motion, that is we have the law of inertia. We have the second law, which states that force is equals to mass times acceleration. And we have the third one that says for every action, there is equal and opposite reaction, right? So all these laws, they hold it only for point objects. That is an exception, that these laws, they hold for point objects. Okay? Now, what do we know about the point object? First of all, a point object means its impact is very small. If you apply a force at any point, so it is not distributed. It is just a single point. But in reality, we have something which is called as a rigid mass. So we will also bring about our attention towards a rigid mass. So what is a rigid body? We have here a rigid body. First, let's see what is a rigid body. A body whose dimensions a body which consists of more than one particle, and their relative locations do not change on application of a force. So if you in reality, whatever objects we see, all the objects, they are rigid bodies, or they are not made up of a single object. At least if they are not rigid, they are not made up of a single object. So here we consider a rigid body. So let's say you have this rigid body which consists of a number of masses. So there are a number of mass, you have mass m1, mass m2, mass m3, m4. So in this way, there are a number of masses of which this rigid body consists of. Okay, it's not a single piece of mass. Any object you consider, it's not a single piece of mass. For example, even if you take one molecule, so that a single molecule is also not made up of a single mass. Even if you consider a single nucleus, so that is not also made up of a single mass. That is also made up of a number of masses. So it depends as per our definition that what things we are dealing with, what is the size of the force that is acting. So here we have observed this to be a number of masses. You have the mass m1. Let's say I have the mass m1, I have the mass m2, I have the mass m3. So on, we have discussed up to now how to find out the position of the center of mass. So in the last class, we discussed about the center of mass. The position of the center of mass is found out by the formula m1r1 plus m2r2 and so on, divided by m, which is the total mass. So this was the formula which we did for x-axis, for y-axis. For example, if we did for the x-axis, so we wrote like this: x center of mass was equal to m1 x1 plus m2 x2 plus so on, and divided by the total mass. The total was m1 plus m2 plus m3, so on, right? So this is what we have the center of mass. Now suppose for this mass, we have center of mass located somewhere here. Let this be the point of the center of mass. Let this be the center of mass. This is our center of mass. Means the whole mass of the system is supposed to be concentrated at this point. Now see the effects which will be produced if you apply some force on it. Let us try to apply some force on it. So if you apply a force on the center of mass in this line towards the center of mass, if you apply a force over here, so do you think the two forces will create the same impact? See, this is the force F2, this is the force F1. So what do you think that the two forces will create the same impact?
No.
No. What will be the difference? What difference we are expecting here? See, the difference we see, the force which is acting on the center of mass, the force which acts in the line of center of mass, this force will provide it a translatory motion. It will make the object move in a translation. So this will provide it a translatory motion. The mass will move in a straight line. When the force is acted on the center of mass, this mass will move translatorily. It will show translation. But if the same force is acted on the point F2, if the force is acted on the point F2, then it will not show translatory motion. Rather, it will show a rotational motion. This object will start rotating about the center of mass. So the effects which are there, they are dependent on where the force is being applied. If you apply the force in the line of center of mass, so that will be your Newton's laws of motion. If you are applying the force not in the line of the center of mass, if you are applying it somewhere else, so it will be creating some other effect. That is the rotational effect. Okay. Also, can you say, is it possible to create a rotational effect by hitting at the center of mass?
So it should be hitting an edge, not the
Yeah.
center.
Yes, we can create the rotational motion even by hitting at the center of mass, but at that time, there should be a pivot point. That means it should be pivoted at any point. Either it should be pivoted here, here, or at any point. It should be pivoted at any point. So see, for a rigid body, the point of application of force is important. Okay. So the point of application of force will create a rotational motion. Now, if you suppose I am applying the force F2, now this will create a sense of rotation which will be in the clockwise direction. This body, rigid body, will rotate in the clockwise direction. Am I correct? Yes, the rigid body will rotate in the clockwise direction if the force acting is F2. And if I apply a force F1 over here at this point, so what should be the sense of rotation then? Should it be clockwise or anti-clockwise?
Anti-clockwise.
This would be anti-clockwise. Okay. Now we observe here that the point of application of force is important, and hence the distance of the point of application of force from the axis or from the center of mass. If there is any axis, then we will look up point of distance of application of force from the axis, or we will, if there is no point of axis, we will observe the center of mass. Right? If there is no axis, so in that case, the center of mass will act as the pivot point. It will act as the axis. Okay. So here, if there is somewhere else we have a pivot point, so it will be rotating about that. So Now we come to the rotational force. Okay. So as we know, depending on the point of application, we can create the rotational effect, and therefore to create the rotational effect, you have the rotational force, and that rotational force we call this rotational force as torque. So rotational force, the rotation or the turning effect depends on the point of application of force. That is, it depends on the distance of point where force is applied from the point from axis. So as you know, if any object starts orbiting, if any object starts rotation, so there will be a fixed axis and the whole body will be rotating about that axis. So this rotational force is also called as torque. It has been given another name called torque. Now the magnitude of torque, it depends on the amount of force which will be creating the rotational effect, and as we have discussed that it also depends on the point of application. So suppose you have a body, let's say we have a rigid body, and for this rigid body we are applying some force. Let's say you have the axis of rotation. Suppose you have this axis of rotation passing through this point. Let this be the axis of rotation, and through this axis of rotation it is to be rotated. Now if I am applying some force at this point, let's say I apply some force F over here, so the torque is calculated, or torque or the rotational effect, so torque or rotational force is equal to, or it is calculated by R times F sine theta. R times of F sine theta. R is the, here we say R is the distance of force. It is the distance of force from the axis. From axis. So distance of the point where the force is acting, distance of that point from the point of application of force. So that is R. Then F is the force that acts. Force. What is theta? So theta is the between angle between line of action of force, angle between line of action of force, angle between line of action of force and axis, line of action force, and R, which is the distance from the axis. Okay, so welcome Dhananjay.
Good evening, sir.
Good evening. Joined a little bit late, and today we had just started with the rotational dynamics or the rotational forces. Okay. See the rotational force, how it works. The rotational force, or Suppose I want to rotate an object. Basically, we started with the discussion of a rigid body. So any rigid body means a body which consists of more than one particle and the relative locations do not change on application of a force. So if you apply a force at anywhere, so it should not get deformed. Its shape should not change. So such a body we call as the rigid body. In practical, we do not observe any rigid body. All the bodies which are there, they get deformed. They are elastic to some extent. Okay, so all of not there is none body which is perfectly rigid, right? So, however, any solid body can be considered as the to be rigid to a certain extent, and therefore we apply our definitions here. Now, on the rigid body, we are discussing for the point of application of the point of application of force is important. We have studied about the Newton's laws of motion, where we have seen that the force acting on an object F is given by ma. But this definition is applicable only for point objects. So this definition is only for point object. Whereas we are considering a rigid body where our point of application is very small. We are not applying force on all the parts. We are applying force on a small part or small portion of the part. Now, when we apply our force, so point of application of the force will create different effects. If we apply the force F1 at the center of mass, so this will produce a translatory motion. This green dot is the center of mass, and if you apply a force F1, so an acceleration will be produced in the direction of force, right? But if you apply a force F2 at a point other than the center of mass, so I have a point F2 here just above it, and if I apply a force F2 over here, so do you think that again it will create the translatory motion? No. Now it will not create a translatory motion. Rather, it will make the object rotate. It will rotate the object in the clockwise direction. So here it will create a rotational motion in the clockwise direction. Okay. Here, if I apply some force F3 over here, so the force F3 will also make it rotate, but in the anti-clockwise direction. Okay. So we observe here certain effects which are related, or there are certain effects which are related to the body on the points of application of the different points of application of force will give us different rotations. Okay. So just one, any doubts?
No, sir.
No.
No, sir.
Okay. So see, on the depending on the point of application. So as you can see, if this force is very close to the center of mass, a larger amount of force would be required to rotate. But if this force is located to a greater distance from the center of mass or from the axis, a small amount of force would be required for it to rotate. For example, we have seen the that nut bolt. If you try to open a bolt with the help of a wrench, have you ever tried to open up any nut bolt or a nut bolt with the help of a wrench?
Yes, sir.
Yes. So is it difficult to do it with hand or with a wrench? Which one is easy? Suppose you want to directly open it with your hand by unscrewing it like this, or you want to use a wrench.
Wrench, wrench.
Yeah, you have to use a wrench. With hand, maybe you are not able to open it. So what happens over there, if you observe from the axis, we increase the distance. When we attach a wrench to it, so we increase the distance of point of application of force from the axis. So from the axis, we apply our force over here, which is a little bit distance away from the axis of rotation. So this will create a greater amount of torque to rotate it. So that is what we are discussing here, that amount of rotational force or torque which is required for an object to rotate, it depends on r, which is the distance of point of application of force from the axis of rotation. So suppose in this case, I take here an example where we apply the force and we will see the, okay. So here, if you have some force F acting like this, just come to, okay. You have some force F acting like this. So if you want to find out the torque, so we must find out the distance of the point of application from here. So this is your R. You have R, and the angle between, this is the angle between R and F. So the amount of torque or rotational force can be computed as RF sine theta. Got it?
Yes,
Now see, as we have seen, the rotational force is required for rotation to be produced. A rotational force is required for the object to rotate, and that rotational force is called as torque, which we call RF sine theta. Now I'll just ask one question. If you can answer, just try to answer this. Why the door handles are attached to a side of the door? Why not in the middle?
So they are the door is attached to a pivot at the edge, so it needs
Yeah.
to be off. So the mass applied needs to be at its opposite.
So your question, I'm writing, your question is why door handles are attached to the, so why door handles are attached to the right or side away from axis of rotation? Yes.
So the motion is more, the movement.
Why? See, if they are attached to a distance, if they are attached to a side, so what happens? See here, suppose you have this is the axis of rotation, and let's say you have the door. So you have the door now. The door the door is pivoted to this axis. So hence the door can be rotated about this axis like this. Now, if I put up the handle here, I can put up the handle over here. So which one do you think would be better?
The one on the
I'm
edge.
on the edge, okay? At the point P or towards the edge, it would be better. Because if you observe the distance of the point from the axis, so distance of the point from the axis is more for B. Okay. So just application of a small amount of force at the point B will create the required rotational effect. Okay. Whereas it would require a larger force if you try to push it from the point A. So that is why the door handles are attached to a side away from the axis. So we can also explain it in terms of like this, that torque, generally represented by the symbol tau. So torque would be equal to Rf sine theta. So to increase the amount of distance, you can rotate it quickly. The rotational effect can be created by increasing the distance from the axis of rotation. Or you can say the amount of rotational force can be increased by increasing the distance of axis of rotation, distance from the axis of rotation. The same thing works for the wrench also. For the wrench also, it's the same thing. The longer the wrench, the much easier will it be to open. So that is why you might have seen truck drivers opening those truck nuts with a very long rod, which increases the distance from the axis of rotation. Okay, so we get our torque equals to Rf sine theta. So I hope you have understood about the rotational force torque. Okay, so let's see, let's do another question. Let's do another question. Find the torque acting on an object. Find the torque acting on an object if 24 Newton force acts at a distance of 20 centimeter from the axis at an angle of 30 degree with distance. Okay. So find out the amount of torque that acts. Just one, can you find out the force? Find out the torque. Dhananjay?
So the distance needs to be in meter, right?
Yeah, so convert it in meter and obtain the answer. Convert it and obtain the answer.
The 6.
Yes.
The 6. 6.
144.
How much?
144.
The 6.
Okay, so you will be getting your answer as torque equals Rf, where R is 0.2 multiply F, which is 24 multiply sine 30. So sine 30 is 1 by 2. Okay. So you get 2.4 Newton meter. Is this what you get? Just simple application of the formula. Torque equals Rf sine theta. R is 0.2, F is 24, and sine 30 degrees 1 by 2. So getting it 2.4 Newton meter. So will you do one more question now? So see, a range of 20 centimeter length. Yes, sir. Find the length of wrench required to unscrew a bolt that require a torque of 40 Newton meter. The maximum force that can be applied is 25 Newton. Consider force to be acting perpendicular to it. So find out this. Okay,
1.6.
so 1.6. Dhananjay?
1.6 only, sir. 1.6 meters.
Okay, so let's say you will be using the formula torque equals Rf sine theta. So torque here is 40, should be equal to R, which we find out, multiply F, which is 25, and your sine 90 is 1. So you have sine 90, which is 1. So 40 over 25 will be equal to R, and you get 8 by 5. That's R. Okay, so that's the answer you got. You
Yes,
got
sir.
this answer? Okay.
Yes,
So
yes.
by both of you, join classes on time. Okay, if you have not understood anything of out of these, I'll be repeating it in the next class if you want. Okay. But this is a very important part. We'll also do the balancing of an object, how objects are balanced. Right? Okay. Bye everyone.
Bye, sir.
Bye, sir. Have a nice day.
To you.